Good day once again. Welcome back to our video tutorial regarding house electrical design. So in my past three videos, we discussed about single family dwelling up to 50 square meter floor area with a single circuit of not exceeding 3680 volt amperes. So now, in our example today, we will be demonstrating single family dwelling unit up to 150 meter squared floor area. So be a bigger floor area, not more than 6 circuits. So having 2 up to 6 circuits. So yan po kasi po we have already bigger floor area of 150 square meter floor area. Okay, we start the computation of loads and then get the circuit requirements. Okay, let's start. The dwelling has a floor area of 140 square meters. It has the typical household appliances, including one 1.5 horsepower air conditioning unit. So we have some household appliances which is have no specific uh, load requirements. So in here we will again create a general purpose branch circuits. So to get the total load, letter A, general lighting and convenience receptacle load. So 140 square meters times 24 volt amperes per square meter, as we discussed last time of the dwelling units for occupancies. Here, table 3.3.1.2b for general lighting loads by occupancies. So we have again dwelling unit occupancy. So our corresponding uh, load per square meter is 24 volt amperes. So yan po siya. Ito po yung 24 volt amperes. Okay. So 140 square meter times 24 volt amperes per square meter is 3,360 volts. So by using calculator, we get these results. So the computed load is 3,360 volt amperes divided by 230 volts. Our system of supply is now it is equal to now 14.6 amperes. So by computation, again, just show you. So 140 times 24, 140 times 24 volt amperes per square meter is equal to 3,360. So we divide it by 230 volts. We have 14.6 amperes. 14.6 amperes. So now, one branch circuit of 20 ampere would be theoretically adequate. So here, in theory, we will one branch circuit of 20 ampere is okay. However, for flexibility to allow for future needs, provide two 20 ampere branch circuits for lighting and convenience outlets. So we will have to put two branch circuits so we can divide this load. So it's much better. So ito po yung ating circuit number 1, circuit number 2. Yan po siya of 20 ampere. po. So, meron po ako rito table in our right just to make a list of our branch circuits. So, circuit number 1, circuit number 2, yung general lighting po natin and receptacle load. So, 20 ampere each. So, we already have created 2 branch circuits. So, again, the letter B, small appliance load. So, in Philippine Electrical Code, it says there that we can have 120 ampere for small appliance circuit at 1,500 volt amperes. So, yan po yan. So, we already have allotted again 1 branch circuit. So, ito po yung circuit number 3 natin, which is also 20 ampere. So, ito po, number 3 for small appliance load, 20 amperes. So, ito pong small appliance natin, magko-concentrate siya sa kitchen loads. Kasi po yung cooking and heating appliance natin, matataas po ang rating. So, we have created a dedicated branch circuit for it. Yung mga typical household appliance natin, dito na po siya papasok sa general lighting and receptacle load. So, we already have created 3 branch circuits. Alright. So, C, laundry circuit load. So, in Philippine Electrical Code, to create a multi-branch circuits, we have to provide 120 ampere laundry circuit. So, it is a dedicated branch circuit as per Electrical Code. So, at 1,500 volt amperes. So, again, we have 1,000 volt amperes. So, ito na po yung ating pang-apat, number 4 na branch circuits na 20 ampere. So, again, I put it in my table. So, circuit number 4, laundry loads, 20 ampere. Yan. So to get everything, to get our total load for the tree, we will have to add all of these. So 3,360 plus 1,500 volt amperes plus 1,500 volt amperes. The total should be around 6,360 volts. So no need to compute for it. I already have total. So we have subtotal load of 6,360 volt amperes. So applying the Philippine Electrical Code table on the demand factors. Yan po. Table 3.3.2.2, feeder demand factors for general lighting load and small appliance load. So for dwelling units occupancy, the first 3,000 volt amperes load is we will have to compute 100%, the first 3,000. So the succeeding 3,000 to 120,000 volt amperes, we will have to compute it at 35%. So we will apply these demand factors. Okay. So first 3,000 volt amperes at 100% demand factor is 3,000 volt amperes. So remainder at 35,000 demand factors. So 6,360 minus 3,000. So we have remainder of 3,360 times 35%. So 1176 volt amperes. Ito po siya. Okay. So to get we will again have to compute the other loads with each, which is 1.5 horsepower air conditioning unit. So ito po siya. 1.5 horsepower ACU. So ang full load currents po natin Meron din po ulit tayong table na gagamitin. So ito po. Lahat po itong tables nasa Philippine Electrical Codes. Ipapalo lang po natin. So table 6.6.12.2, full load currents in amperes, single phase alternating current motors. So we have in our example 1.5 HP. Ito po, 1.5 HP. So sa 230 volt system, we have 10 amperes. 10 amperes. So ito po yung 10 amperes using this table. So 10 amperes times 230 volts at 100% demand factor, we have 2,300 volt amperes. So sa 10 amperes po, yung branch circuit protection po natin is 20 ampere. So we will have to provide 120 ampere for this 1.5 ACU. So yung our fifth circuit is 20 ampere. So ito na po. Our number 5 branch circuits is ACU loads 20 amperes. So we have created now total of 5 20 ampere circuit rating loads. So 5 po yan. So to get the total, total net computed load is, if we add everything here, 3,000, 1176 and 2,300, we will be getting 6,476 volt amperes. Yan po, total net computed load. So upon getting everything, we can start to get the circuit requirements. Diyan na po tayo magsisimula. So we determine 6,000, we have 6,476 volt amperes. So circuit requirements, use 520 ampere to circuit for our branch circuits. So ito na po siya, 520 amperes. Then we will have to discuss since we only have common 20 ampere circuit, we'll get the size of conductor for the branch circuit. So ito po, using this table 3.1.2.6 summary of branch circuit requirements. So we will be using again TW or THW conductor. So if our circuit ratings is 20 amperes, our circuit wires will be 3.5 mm squared. So 20 ampere circuit wires are 3.5 mm squared using this table. Take note of this, 3.1.2.6. So ito na po siya. Use 3.5 mm squared THW or TW copper wire for branch circuit natin na 20 ampere. Okay. So tapos na po yung sa branch circuit conductor. So we will have to get the service entrance conductor para po sa bago pumasok siya ng branch circuits, meron po tayong service conductor from the main supply. So to get it, we will have to add the total computed load 6,476 plus 25% of the highest motor rated, which we have only one. So 2,300 volts po yung highest motor natin at 10 amperes. So if we add this one divided by 230 volts, we get 30.66. So I'll just show you 6476 plus 25% of 2,300 full load current of our air conditioning. Yan po, 7,051 divided by 230 volts. Yan po, 30.66 round off. Round off na po siya. So, upon getting 30.66 volt amperes, we will use the table for the ampacity, conductor's ampacity. So let me get it, our table, for a while. We will be getting the size of conductor. So remember, we have 30.66 amperes. In table 5.3.1.16, allowable ampacities of insulated conductors, if we will be going to use TW for 60 degrees or THW for 75 degrees, we will look for 30.66. So 30.66, so the next largest ampacities we have to look for is above 30, so 45 on this row. If we use TW wire, so above 30.66, so it's on this row. So the same row, we will determine that the size of the conductor is 8.0 mm squared. Yan po. Dito na po tayo kukuha sa row na to, above 30.66, 8.0 mm squared. So that's why we have here 8.0. We have to use 8 mm squared, 8 mm squared THW wires or TW wires as service entrance conductor. So I hope it's clear paano pagkuha po nito, 8.0 mm squared THW wires as our service entrance conductor. So now getting our service protective equipment, our main breaker, maximum current rating of protective equipment. So it is the sum of all full load currents plus 250% of the single motor we used, which is 2,300 volt amperes. Yan po siya. So kung papakita ko lang po sa inyo kung bakit may ganon, ito po. In table 6.6.12.6, maximum rating or setting of motor branch circuit. So type of motor, single phase. If we are getting the inverse time circuit breaker, we multiply po natin yung ating motor ng 250%. 250%. So yan po, kaya po meron dito 250% para alam niya po kung saan siya kinuha. So if we add everything divided by 230 volts, we will come up for this one. So I'll show you how. Okay, 3,000 volt amperes using our scientific calculator plus 1176 volt ampere plus 25%, 25%, which is 2.5 times 2,300 is equal to 9926 volt ampere. So divided by 230 volts to get the current. So it's 43.15 or 16 round off. So 43.16 amperes. So to get our circuit breaker rating, we will again use the code So we will always refer to our codes para po hindi po tayo malito. So we will again use the codes. I'll show you. I'll try to find it. Okay, for a while. Ito po. In section 4.5.1.5, standard ampere ratings for fuses and inverse time circuit breakers. So we have this 43.16 amperes. So to get the circuit breaker rating 43.16, so it's very near in 45, so we'll have to jump to the next larger rating, which is 50. And po 43.6, so we jump up, is very near 45, so we jump up to 50 ampere circuit breaker. So yan po, dito po kinukuha yan sa section po na to, 4.5.1.4.5 of Philippine Electrical Code. So we will have to use 50 ampere 2-pole 240 volt circuit breaker. So yan po yung circuit requirement, nakuha na po natin. So here I draw one single line diagram of our house design. So 50 ampere 2-pole as our main breaker. Ito po, service equipment protective device. It will be our means of the disconnection of the branch circuit. So this is the disconnecting means. 50 ampere 2-pole circuit breaker. And then we under it on the load side we have the 5 branch circuits. So 5 20 ampere branch circuits. So 1 2 3 4 5. Then if we have one spare if we have some future expansions. So yan po. So yan po ang pagde-design or pagko-compute ng single family dwelling unit up to 150 square floor area, not more than 6 circuits. Yan po. Okay po, sana po may natutunan kayo sa aking fourth video tutorial regarding house electrical design for multiple branch circuits. Okay po, next we will see you in our next topic, next video tutorial. Don't forget to subscribe to learn for self improvement. Thank you very much. Bye bye. Cheers.